Hey guys, I thought I would do a quick little question and answer here about question number 10, cars and trains and the distance they're traveling. So when we're looking at questions like number 10 or questions like number 8, which is a cone, we don't start with rates, we put rates into the problem. So we have to have a formula to begin with. And the formula we're going to start with in number 10 is the distance between the car and the train. So that's why I've got a little a squared plus b squared equals c squared at the top here, because that's the information that's talking about our distance. And I did a little check mark here because I'm talking about three different rates: the rate of the car, the rate of the train, and the rate of the distance change. So I do need three variables for that. So when I was working through my problem, then I found the rate for A, which is the car. I found the rate for B, which is the train, and I found the rate or put the rate in for the how the rate is changing between the car and the train. And then A squared is 2A, and it's dA dt, so that's the speed of the car. B squared is 2B, and dB dt, so that's the speed of the train. And same thing, dC dt is going to be the distance change between the car and the train. So like all of our problems, it's a formula first. Make sure the formula you have has the right number of rates in it. So if you're doing a cone question, too many variables. So we do some triangle relationships, and we work it down to get two variables for two rates. But this is three variables and three rates. So after we get our rates, we get our moment in time. We're given all kinds of information directly. A and B are directly given to us. dA, which is the speed of the car, and dB, the speed of the train, are given to us directly. But before we can solve the problem, kind of that Trek layer, we have to find how far apart the car and the train are. So we found that on our own. This says find C on your own. Very nicely printed. So let's see if we can, no, that's not going to change for us. So anyways, that's how you solve a triangle problem, right? Start with if it's a distance and go from there. Hope that helps.